Hi, my name is Emily and I'm going to show you how you can define a state space model for a spring mass damper system and simulate its step response in LabVIEW. I'll step you through modeling this second order system and simulating its transient response using tools from LabVIEW's Control Design Toolkit as well as the textual math component of LabVIEW MathScript. So I'll start off by opening a MathScript window here from the LabVIEW Getting Started splash screen. And I'll first click on the load script icon to load an M file that I've already created that has the necessary commands that will define and simulate my second order system. So first you can see that I've defined my system parameters, mass, stiffness, and damping. I've also got my state space matrices that I've derived from my equations of motion for the second order system, A, B, C, and D. And then I create my state space model using the state space command in MathScript, as well as plotting the step response using the step command. So next, what I'm going to do is I'll click on this green arrow up here, Run Script, and that will basically run the M file. And you can see that over here it's defined my state space model, and in addition to that it's got my step response here plotted for us. And what I'd like to do now is let's go back and change these system parameters, mass and damping and stiffness, and see what the second order response will look like. So let me just type that differently here and click Run Script again. And we can see that indeed by changing those system parameters the system will indeed behave differently. So we've just explored how you can interactively work with an M file script in the MathScript interactive window. Let's now move over to LabVIEW's graphical programming environment and examine how I can easily create a more interactive simulation by mixing graphical and textual programming. So first what I'll do is I'll load a skeletal VI here that I've already got going here, and I'll use here on the block diagram I'll use a MathScript node and import the M file that I just saved previously here, spring mass damper here .m. And first I'll delete these system parameter constants. I can change these parameters on the fly if I wire them to controls on the front panel. So now I need to create an input to the MathScript node for the system stiffness and wire it to its control here. So I'll just put K there and wire it to this control icon. And I'll do the same for stiffness, add an input here, or excuse me, damping, and the same for mass, and wire them to their corresponding controls. And the next thing I'll do is I'm going to delete this line here as well. I'll have LabVIEW create the step response for me, so I won't be needing that command line. And so now I need to create an output node for the state space system model. And I'll right click and make sure that's represented in state space form. So now if I right click and bring up the functions palette here, I'll go down to the Control Design and Simulation subpalette where I can go to the Model Construction VIs, and now I can have LabVIEW display the state space equations for me on the front panel. So I need to wire the input to my system model output node there, and I'll wire the output of that VI to the corresponding indicator state space equation. And I'll do the same for the step response. I'll go back to the Control Design and Simulation subpalette where I'll go to the Time Response subpalette and select Control Design Step Response VI. And again, I'll wire the system model to the input there, and I will wire the output to the step response graph indicator. And we can see that if we go to the front panel, I've got these nice controls here for the mass, damping, and stiffness, and I'll just click Run, and we can see that indeed we get the same graph that we saw there in MathScript, But now we've got this nice state space representation of the state space matrices here. And now I can go back and change these system parameters quickly and easily here just by clicking up and down on those keys. And I'll click Run again, and now we can see how the system changes by quickly changing those system parameters. So now I hope you've seen how easy it is to model a dynamic second-order system and view its transient response both in MathScript and in LabVIEW, and thank you for joining me.